A hotel ranks 240 rooms when the daily price is $60. For each $3 increase in the price, 3 fewer rooms are rented. Find the room price that maximizes the daily revenue. All right, so when we look at a word problem, not every single time, but most of the time, what we're tasked to do is spelled out for us in the last sentence. And in this case, we need to find the price of the room that maximizes the daily revenue. So in order to find this, we need to come up with an equation for the revenue so we can take the derivative and then find the point that maximizes the revenue. And then, of course, we can interpret that. So the first thing that we need to do is find the revenue equation. All right, now the rest of the problem is going to give us clues on how to find that revenue equation. Now we know that revenue is equal to the price times the quantity. We have all the information we need given in the problem to find the price equation and the quantity equation. So let's find the price equation first. Since we're going to let X be the number of $3 increases, our price is going to be $60 because that's what we're starting with, plus $3 times the number of increases. So, for example, if we had 2 increases, that would mean I would have $6 in total increased. So I would have 60 plus the $6 of the amount that's increased to give me $66 for the price. Okay, so there's our price equation, and then let's find the quantity equation next. Now we're also going to let X here be the number of increases because that's how it is describing the relationship in the question. It says for every $3 increase in the price, there are 3 less rooms rented. So we start with 240 rooms, but every time we do a price increase, which is our X, there are 3 less rooms rented. So I need to subtract 3X. So if there are 2 increases of $3, then I would take 3 times 2, which would give me 6. So that's 6 less rooms that are being rented out. All right, so now we have everything we need to set up our revenue equation. We have our price times our quantity, which is 60 plus 3x times 240 minus 3x. There's our revenue equation. Now let's expand it so it makes it easier to find the derivative. All right, so if I take 60 times 240, that gives me 14,400. Then if I take 60 times the negative 3x and a 240 times a positive 3x, that's going to give me a 540x. And then when I take 3x times a negative 3x, that gives me a negative 9x squared. So this is our revenue equation expanded, and now it makes it easier to find the derivative. Now remember what that x represents. Let's write it down again down here. X is the number of $3 increases. Okay, so now I'm going to take the derivative. All right, so the 14,400 disappears because it's a constant. The derivative of a constant is 0. When I take the derivative of 540x, I get 540. And then when I take the derivative of minus 9x squared, that's going to give me a negative 18x. All right, so here's our derivative. Now, in order to find relative maxes and mins, we need to find critical values. So in order to find critical values, we need to set the derivative equal to 0. All right, so we have 0 is equal to 540 minus 18x, and we need to solve that for x, which will give us the number of $3 increases that maximize this revenue equation. Okay, so when I solve this for x, I'm going to add 18x to both sides and then divide both sides by 18, and I'm going to get that x is 30. So that means when we have a maximum revenue, that means we have $33 increases. How do I know for sure that this represents a maximum? I know that it's a maximum because when I look up here at our equation that we figured out for our revenue, here's our equation. Notice that the leading coefficient is -9, and this is a quadratic, which means if we were to graph this, we would have an upside down quadratic function. And the relative maxes and mins here, the only one that's available to us is a maximum at that vertex. Now, if you didn't pick up on that, and you didn't realize that that was a maximum by looking at the equation, remember the alternative is that you can use the second derivative test to determine if it's on an interval that's concave down or concave up, which would then give you the information you need to decide if it's a maximum or a minimum. Okay, so since I know that the value of x that maximizes the revenue, and we're trying to find the price for that, I'm going to go back to the price equation, which was 60 plus 3x, and I'm going to plug in x is 30. That will give me the price that maximizes this equation. So I'm going to have price, plug in 30, so this will give me 90 plus 60, which is $150. So this is the price that maximizes the revenue. Now, that's what we were tasked to find, right? It said, find the room price that maximizes the daily revenue. Now, if I wanted to take it one step further and actually find the revenue, I would find the revenue equation. So we'll add this as an extra step. This is extra. It's not part of the problem, but it's good practice. If I go back up to the revenue, here's my revenue equation that we got before we took the derivative. I wanted to find the actual revenue. So I would plug in x is equal to 30, and that would give me the corresponding revenue for when x is 30, which would be the maximum revenue. So I'll let you do the math on that if you want to use it for practice. But the final answer would be we would need the room to cost $150 in order to maximize the revenue for this hotel, and it would be daily revenue.